Hello everyone. In last lecture we finished all the topics about the regression and including ridge regression and lasso regression. Especially lasso regression is very useful for the feature selections. And in today's lecture we're gonna move on to a new topic, completely new topic, which is also a very popular machine learning tool, which is called the decision trees. Actually, decision trees can also be used for both classification can also be used as a regression tool. So for example, so here is one, and also usually, I think one motivation here is when you create a regression, right? You always need to think about the regression function. For example, hx is some x multiply some w matrix, right? So the problem is if you so which can be also written as alpha plus like a beta 1 x1 plus beta d xd. And we also talk about the regression can be linear regression or lasso regression, ridge regression, logistic regression can also give us the nonlinear pattern of data. So which means you need to design some feature functions, for example, to include some beta 1 x1 square or something, or some interaction terms, maybe beta 1 2 x1 x2 and so on. If you include more features base, you will have some. Your linear model can also capture the nonlinear pattern, but the problem in reality, especially when your dimension feature space is high, it's hard to imagine what nonlinear functions we should use. Because we cannot visualize this high dimensional scatter plot, right? And the decision trees give us a natural way to model the nonlinear method for the both classification and the regression. Okay, so this decision tree is a nonlinear method. For both classification and regression. So this is totally non-parametric methods, and we do not need to worry when we create a decision tree model. You do not need to worry about what's your regression function format. So the regression function format in the decision tree is determined by the data, which is a lot of advantage. Okay, actually, the decision tree has two structures. One is called nodes, and branch. Branch means splitting rules. Okay, for example, it's like a trees, but here usually we have the trees from the top to the bottom. Typically, and we call this bottom one is called a root node. And for the terminal node, we call it a leaf node. And all the inside node is called the internal nodes. Okay. So specifically for the nodes, if it's not leaf nodes, we call it, there are two types of nodes. One is called internal nodes. There are two types of nodes. One is called internal nodes. Which contains the splitting rules. It contains information about test features. I will give you 1 minute. Test feature and the splitting value. Okay. Another one is the leaf node. Specify the class of H. Specify the class output, class label. So here, let's talk about the classification first, and then we will talk about how to use the tree for the regression. Okay, so tree for classification. So here is one example. Suppose we want to so suppose I want to say if I want to go out picnic in this weekend. So suppose y to be the variables we want to classify. So suppose y equals to during this weekend. Okay, and x, so we want to predict this y, and this x is depends on we have some input features. X could be wind. Is this gonna be a windy day this weekend? X2 could be the how about the weather? For the wind, we can call it wind speed. If it's too windy, I do not want to go out. I only go out if the wind is mild. Okay. Also the weather could be cloudy. Could be sunny. If it's cloudy and sunny, I will go out, and if it's rain, I will stay home. Okay, maybe we have another feature. Humidity. If it's hot and humid, it may not be comfortable to travel outside, right? So that's few variables, and we want to use this variable to predict if I gonna go out for picnic or not. So general, we just probably how we can use construct decision trees. We can ask survey questions. Probably I check the weather report. So this is x2. Okay. So this is called classification. So this is test feature, right? Test feature. Okay. So if the weather is sunny, if the weather is sunny, and if it's not too humid, so maybe the second variable we want to check is x2, x3, humidity. If the humidity is greater than 75%, but if the weather is sunny and the humidity is too humid, I will stay home. So I won't go out. So no, stay home. So if it's less than equals to 75, okay, I say yes, I will go outside. Second case is for the weather, if it's cloudy day. Okay, I will go out for picnic. It's nice. And if it is raining day, then I may check how about the wind speed. So I can ask the wind. If wind is mild, I will go out. Okay. If the wind speed, testing feature wind speed is less than or equals to 20, I will go out for picnic. Okay. If the wind is too strong, greater than 20 miles per hour, say, and then I will say no, I will stay home. Okay. So this is an example of the classification tree. This is an example of the classification tree. So what we do is we start from the root node, and depends on. So suppose we have some new data point. Okay. For example, we have the new data point is x1, x2, x3, and our x1 is the humidity, is the wind speed, right? If wind speed is say as 10 miles per hour, and x2 is suppose this is a sunny, and x3 is the humidity level, for example 60%. So if we have some new data and we want to guess if I'm gonna go out or not, if we train our model so that our model give us this classification tree, then what we do is we start from the root node, and the test feature in the root node is x2. Okay, x2 is sunny, so if we go to the left, and then we check x3. The humidity is 60%, so it's less than 75%. Also, it's a yes. So we're gonna predict a yes here. Okay, so this is how we apply the classification trees. Actually, each tree divide your domains, divide your feature space. Feature space into hyperrectangles. Okay. For example, in this case, we have the three-dimensional feature space. In other words, Suppose we call this is x2, the weather space, and this is x1. X1 is the wind speed, right? Wind. X2 is the weather, right? And x3 is the humidity. Okay, so actually this tree cut this domain space, this feature space, into the pieces. For example, first it cuts we have the x2 weather. We have 3 categories: sunny, rainy, cloudy, and raining, right? So okay, and we also so each node we split the space. So for example, x3 is humidity. So if x3 if it's sunny and the x3 is greater than 75, we say no or yes, right? So if it's sunny, it's 75%. So sunny and 75%. So this split the feature space into 2 hyper triangles. And also we have another features, right? Wind speed. So wind speed is you follow the rain branch, right? So in this rectangle, the rain branch okay. If the wind speed is less than 20, okay, the wind speed is less than 20, we say no, or we say yes, and otherwise we say no. So when it's rain and it's less than 20, so maybe I will use different color to split this feature. Okay, so in other words, each tree kind of divide the features into the hyperspace, hypercubic, hyperrectangle, and on each domain, on each region, we give an answer. For example, where is this node? Where is this node? This node means it's sunny, and x3 is greater than, so sunny x greater than, so this node is here. So on this upper left rectangle, hyperrectangle, it's the answer is no, right? And the bottom part is yes, and the middle part is yes, and the right front is yes, right? And the behind one is no. Okay, so that's kind of, we use this to train our trained model is look like this, and this is how we interpret this tree, how we actually implement this tree behind. Okay. So there are some summaries here. I'll give you a little bit of summary. The tree cut the space into rectangular cells. The tree methods works well with both categorical and quantitative features. Okay, and the results are more interpretable. And we have with so for example, this x2 is sunny, cloudy, or rainy. It's categorical data, right? But under the x1 and x3 are wind speed. These are quantitative variables. And the results are easiest to interpret. Also, the decision boundary can be arbitrarily complicated. So here I'll give you one more example plot here. For example, for the first case, this is a plot from our textbook. For the first case, case 1, this blue dot and red dot are linearly separable, so we can find a line separate them. So in this case, we can use the support vector machine or the logistic regression. We can easily find this decision boundary. But if the labels are not linear separable, for example, the second case, no matter which line you use, you're gonna have a lot of the misclassified cases. Okay, but if we are the humans, right? We can use the eyeball. We can directly see. If we cut our decision boundary this way, this will be the better decision boundary. Okay. On the other hand, for the linear case, the decision boundary will give us these little rectangles, right? Little rectangles, and then we can decide red or blue. But for the more complicated cases, which cannot be easily determined by the linear decision boundary, sometimes the regression tree can give you better results. Okay, so in next I would introduce there are many ways, different algorithms to training the trees. They call it the Bayesian additive regression tree, Bayesian ways, frequentist ways. But today I just give you one method called a greedy algorithm. Greedy top-down heuristic. And we're gonna follow the methods we introduced in the previous methods. We introduce what's the loss function, what's the cost function, and how do we implement to minimize those cost functions. Okay, I will continue in next video.